Hello student, today we are going to discuss some of the question of JEE and these are the PYQs and these classes are arranged by Evershine School. So today we are going to start the class now. Now beta, this is the first question of it. If x lies from 0 to 2 pi, then find the number of real values of x satisfying cos x plus cos 2x plus cos 3x plus cos 4x equals to 0. So now here we have an identity of cos x plus cos y. It is equal to 2 cos x plus y upon 2 and cos x minus y upon 2. So we will use this identity over here. So now I can rearrange them. So first I'm taking cos x with cos 3x and cos 2x with cos 4x. It is given 0. Now apply the identity. It will be 2 cos x plus y upon 2. So 1 plus 3 will be 4. 4 by 2 will be 2x. Now next, cos x minus y. So cos of x minus 3x will be minus of 2x. Minus 2x upon 2, cos of minus x. Now similarly the same identity I am going to use here. So cos x plus y, that will be 2 cos 2 plus 4, 6 by 2, 3x. And cos 2 minus 4, that will be minus 2 by 2 will be minus of x equal to 0. Okay. Now as you know, cos of minus x always equal to cos x. So this can be written as 2 cos 2x cos of x plus 2 cos 3x and cos of x equals to 0. Now something is common here. So the common is 2 cos x. I can take it out. So I'll be getting cos 2x plus cos 3x, which is equal to 0. Okay. Further, I have to apply the identity. So this cos 2 cos x will be as it is. Apply the identity cos x plus cos y. So 2 cos x plus y upon 2, that will be 5x by 2. If I subtract, I'll be getting cos x by 2. Okay. Now simplify it. It will be 2 2s are 4 cos x cos 5x by 2 and cos x by 2, which is equal to 0. Now as you know, each of them will be equal to 0. So the first cos x will be 0. Cos x will be 0. So I can write cos x equal to 0. Cos x is 0, so it will be odd multiple of pi by 2. So x will be either pi by 2 or 3 pi by 2. Because whenever x is 0, it is always odd multiple of pi by 2. From 0 to 2 pi, I'll be getting two values of this, pi by 2 and 3 pi by 2. Next, I'm going to put cos 5x by 2 equals to 0. So cos 5x by 2 equal to 0. Now I want to simplify it. So cos 5x by 2 equal to 0, which gives 5x by 2 equal to odd multiple of pi by 2. So that will be 2n plus 1 pi by 2. Okay. So now x will be equal to 2n plus 1 2n plus 1 pi by 2 into 2 by 5. So here 2 will be cancelled by 2. So x will be equal to 2n plus 1 pi by 5. Okay. Now I can put the value of n, 0, 1, 2 and so on. So if I put n is equals to 1, so x will be equal to pi by 5. If I put n equals to 1, it will be 3 pi by 5. If I put n is equals to 2, it will be 5 by 5. Okay, now I can put 4 here. Sorry, 3 2s are 6 plus 1, 7. 7 pi by 5. Next I can put 4 here. So 4 2s are 8 plus 1, 9 pi by 5. Okay, so these values will lie between this interval. If I put n is equals to 5, it will be more than this, more than 2 pi. So I cannot take that value. Now the last is cos x by 2. Cos x by 2 equal to 0. Cos x by 2 equal to 0. So here x by 2 will be equal to or multiple of pi by 2. So 2n plus 1 pi by 2. So 2 cancel by 2. So x equals to 2n plus 1 into pi. So I can put n is equals to 0. So x will be equal to 5. If I put n is equals to 1, it will be 3 pi. That will be more than the range. So I cannot take that value. So now how many values are there? First I got two values of x, pi by 2 and 3 pi by 2. Here we are having pi by 5, 3 pi by 5. 5 pi by 5 will be pi. Okay. And 7 pi by 5 and 9 pi by 5. And the last is pi. If I make the sets of these values, so I'll be getting pi by 2, 3 pi by 2, then pi by 5, 3 pi by 5, pi, 7 pi by 5 and 9 pi by 5. This pi I have taken, I'll not take it again. Now count them. 1, 2, 3, 4, 5, 6, 7. So your answer will be 7. Your answer will be 7. Okay. Now move to the next slide. If 5 tan square x minus cos square x equal to 2 cos 2x plus 9, then find the value of cos 4x. Okay. So now we'll simplify the LHS. I am given 5 into tan square x minus cos square x, which is equal to 2 cos 2x plus 9. Okay. So I can convert this tan in terms of sec. So it will be sec square x minus 1 minus of cos square x and cos 2x. Cos 2x can be written as 2 cos square x minus 1. I use the identity over here. Okay. Cos 2x will be equal to 2 cos square x minus 1. Now as you know, sec is reciprocal of cos. So this sec square can be written as 1 upon cos square x. And this minus 1 will be as it is and minus cos square x. Okay. Now this is 4 cos square x minus 4 plus 9. Sorry, minus 2 plus 9. Okay. Now but I can take the LCM and simplify it. So the LCM will be cos square x. Okay. So it will be 1 minus cos square x minus cos raised to the power 4x. And it is equal to 4 cos square x plus 7. 9 minus 2 will be 7. Now I can find the cross multiplication of it. So 5 into 1 minus cos square x minus cos raised to the power 4x equal to 4 cos raised to the power 4x plus 7 cos square x. Okay. Now I can multiply the bracket by 5. So it will be 5 minus 5 cos square x minus 5 cos raised to the power 4x equal to 4 cos raised to the power 4x plus 7 cos square x. Now I can make the equation. So if I transpose the term, it will be 5 plus 4, 9. 9 cos raised to the power 4x. Minus 5 will be plus, so it will be 12. 5 plus 7, 12 cos square x. Okay. Now 5 will be as it is, but its sign will be negative. Okay. I just simplified it. and I have converted this into the equation. Now here I can take cos square x equals to t. Cos square x equals to t. I'm just going to put cos square x equal to t. So it will be a quadratic equation, 9t square plus 12t minus 5 equal to 0. Now I can factorize it. So 9t square plus 15t minus 3t minus 5 equal to 0. So 3t is a common factor. I'll be getting 3t plus 5, okay? And if I take minus 3 as a common factor, sorry, 1, it will be 1 is a common factor here. So 1. So I'll be getting 3t plus 5, which is equal to 0. So 3t plus 5, and the other value is 3t minus 1 equal to 0, which gives t equal to minus 5 by 3, and the other value t equal to 1 by 3. What is t here? Cos square x. T is cos square x, okay? Now see. So t is cos square x, which is equals to minus 5 by 3. So this will give the imaginary value. This will give the imaginary value because I am having a negative value of square. Now the other is cos square x equal to 1/3. So cos x will be plus minus 1 by root 3, okay? Now I can take this value. So I got the value of cos x. What I need to find? Cos 4x, okay? So cos 4x will be equal to cos 2 into 2x. Further apply the identity of cos 2x, that is 2 cos square x minus 1, okay? Cos 2x is 2 cos square x minus 1. So this 2 will be as it is. I can apply identity again. So it will be 2 cos square x minus 1, and this minus 1 will be as it is. So 2 2s are 4 cos square x minus 2 and minus 1, okay? So it will be 4 cos square x minus 3. Now I can put the value of cos, that is 1 by root 3. So 4 into 1 by root 3 square minus 3. So 4 into 1 by 3 minus 3. So 4 by 3 minus 3. I can take the LCM. So the LCM will be 3. So it will be 4 minus 9. Wait a minute. 9, this one correct. Cos 4x, 2 cos x, 2 cos square x. Yeah, but then now here we are having a square on it, okay? This one. So I'm just going to put the square. Now see the solution. So a minus b whole square is a square plus b square minus 2ab. So it will be 4 cos square x, okay? Now beta, we have a square on it, so we have to put it here. So it will be 8 cos raised to the power 4x plus 2 1s are 2 minus 8 cos square x minus 1, okay? Now I can put the value. So this is 1 by root 3. So 1 by root 3 raised to the power 4 plus 2 minus 8 cos square x is 1 by root 3 square and minus 1, okay? So 8 into 1 by 9, it will be 2 and 1 plus 1 minus 8 into 1 by 3. The LCM will be 9. So it will be 8 plus 9 minus 8 3s are 24. Okay, so I'll be getting 8 plus 9, 17. 17 minus 24 upon 9, that will be minus 7 by 9. Okay, minus 7 by 9. That means option A is the correct option. Clear? Now beta, we make a quadratic and then find the value by factorization method, and then this value will be rejected due to the imaginary value. I just taken this one. Now simplify cos 4x by the identity and then put the values. Okay, now come to the next slide. S is theta, which belongs to minus 2 to 2 pi. 2 cos square theta plus 3 sin theta equals to 0. Then the sum of the elements of S. हमें sum find करना है बेटा. Okay. Now the question is given 2 cos square theta plus 3 sin theta equal to 0. Generally we are using trigonometric identities over here. First we have to put the trigonometric identities and make the quadratic equation and then solve. Generally we are using same method in all of the question. So here I can write 1 minus sin square theta. हम cos को क्या लिख सकते हैं बेटा? 1 minus sin square theta. Okay, now this will be as it is 3 sin theta, which is equals to 0. Okay, now this will be 2 minus 2 sin square theta plus 3 sin theta equal to 0. Now take minus as a common factor, so it will be 2 sin square theta minus 3 sin theta and minus 2 equal to 0. Now you can find the factorization of it. So it will be 2 sin square theta minus 4 sin theta plus sin theta minus 2 equal to 0. So 2 sin theta is a common factor. It will be sin theta minus 2. Now 1 is a common factor here. So sin theta minus 2. So it will be sin theta minus 2 and 2 sin theta plus 1 equal to 0. So the first bracket gives sin theta equal to 2 and the second bracket gives sin theta equal to minus half. Now beta, this value will be rejected. Why? Because sin cannot be more than 1 and it is 2. That's why this value will be rejected. So I'll take minus 1 by 2. Now beta, sin is minus 1 by 2. Okay, so 1 by 2 is, as you know, pi by 6, 30 degree. Sin 30 is half pi by 6. Okay, now this is negative. That means the value is lying either in third or in fourth quadrant, because according to ASTC, in first and second sin is positive. So here the value of sin is negative. That means either it is lying in third or fourth quadrant. So I told you, how can we find the angle in third? We can write it is pi plus theta, and for fourth it will be 2 pi minus theta. 2 pi minus theta. Okay, so pi plus pi by 6, that will be 7 pi by 6. Now for fourth, 2 pi minus pi by 6. So 12 minus 1, 11. It will be 11 pi by 6. Okay, now this is from the range 0 to 2 pi. But we are having the range from minus pi to 2 pi. So now from minus 2 pi to 0, the value of x will be first minus pi by 6. The other value will be minus pi plus pi by 6. That will be 6 minus 1. So minus 5 pi by 6. Okay. So I get 4 values of x: 7 pi by 6, 11 pi by 6, minus pi by 6 and minus 5 pi by 6. What I need to find? I need to find their sum. Okay, so we are going to add them. The first is 7 pi by 6. The second value is 11 pi by 6. The third value is minus pi by 6, and fourth is minus 5 pi by 6. Now you can add them. Okay, so LCM will be 6. So 7 pi plus 11 pi minus pi and minus 5 pi. Okay, so 11 plus 7, it will be 18. 18 minus 6 will be 12. So 12 pi by 6. If I cancel it, I'll be getting 2. So answer will be 2 pi. So answer will be 2 pi. Clear? Now you can see it. First I converted cos square into sine, and then I have made a quadratic equation, and by factorization method I solved it. I got two values of sine. The one is 2, the other is minus half. So 2 will be rejected because sine lies between minus 1 to plus 1. So this is minus half. So sine is negative. It is lying either in third or in fourth quadrant. So I can solve it by this method. Okay, so I got the values of sine. Another is minus 2 pi to 0. We'll be getting these two values. Now add them to get the answer. Okay. Now the next slide. 2 sine square x minus 2 sine x plus 5 into 1 by 4 raised to the power 2y. Okay, less than equals to 1. This is given to you. Now beta, this is the power of 2. Okay, ये 2 की power है beta. So 2 raised to the power sine square x minus 2 sine x plus 5 multiply with, this is 4. I can write 4 as 2 raised to the power 2 sine square y. Okay, this is also the power of it. Okay, but this is the power of 4. This is the power of 4, which is less than equal to 1. Okay, now beta, in division power are subtracted. So if I simplify it, it will be 2 raised to the power sine square x minus 2 sine x plus 5 minus 2 sine square y. Okay, less than equals to 1. Now this 1 can be written as 2 raised to the power 0. Now I can compare the powers. So it will be sine square x minus 2 sine x plus 5 root minus 2 sine square y less than equals to 0. I can compare the powers बेटा. हमने power को compare किया. Okay, now this one I can transpose the term. So this will be sine square x minus 2 sine x plus 5 root less than equal to 2 sine square y. Okay, now I can solve it. I can find the solution by completing the square method. So this will be sine square x minus 2 sine x plus 1 plus 4. I have just written 5 as 1 plus 4. 1 plus 4. Okay, now less than equal to 2 sine square y. Okay, now but this will be sine x minus 1 whole square plus 4 root is less than equal to 2 sine square y. Okay, now we will analyze it. First I am taking LHS. Now in LHS we are having this value. So sine x minus 1 whole square is always lying from 0 to 1. Okay, now I'm adding 4 both sides. So it will be 4 less than equals to sine x minus 1 whole square plus 4 less than equals to 5. Now take the square root of it. It will be 2 square root of whole sine x minus 1 whole square plus 4 square root of 5. So you can see the minimum value of LHS is 2. So minimum value of LHS equal to 2. Okay, now we will analyze RHS. In RHS we are having 2 sine square y. As we know, sine square y lies from 0 to 1. Now multiply by 2. So 0 less than equal to 2 sine square y less than equals to 2. So the maximum value of this will be 2. Now beta, the minimum value of LHS is 2 and the maximum value of LHS is 2. So we are having the equality either less than equal to. So there is only a single condition in which they both are equal, because LHS has a minimum value 2 and RHS has a maximum value 2. So only the case is possible in which these two are equal. Okay. So I can put them equal to 2. So this one, sine x minus 1 whole square plus 4 root equal to 2, which gives sine x minus 1 whole square plus 4 equal to 4. So sine x minus 1 whole square equal to 0, which gives sine x equal to 1. Now the second RHS, if I put RHS equals to 0, 2, so it will be 2 sine square y equal to 2. So sine square y equals to 1. So mod of sine y equal to 1. So sine x equal to 1 and mod of sine equals to 1. So that means this condition will be satisfying. The second condition will be satisfying here. Okay. Now this is question number 4. Now we are moving to question number 5 here. Now beta, it is given the number of solution of the equation. This one, 1 plus sine raised to the power 4x equals to cos cube 3x. Beta, here we have 3x. Okay. Now see this question. 1 plus sine raised to the power 4x equal to cos square 3x. Okay, cos square 3x. Now I can convert this cos in terms of simple function because it is a multiple of 3. So what can I write here? I can write this one is 1 minus sine square 3x. 1 minus sine square 3x, which is equal to cos square 3x. And this will be as it is. Okay. Now next, I can apply the identity of sine 3x. Identity of sine 3x is 3 sine x minus 4 sine cube x. Okay, this is the identity of sine 3x. We can apply the identity here. So 1 will be as it is. Now I can write this one as 3 sine x minus 4 sine cube x. Okay, we have a whole square on it, so put a whole square on it. And this term will be as it is, 1 plus sine 4x. Okay, 1 plus sine 4x. Now 1 plus sine 4x will be as it is. Okay, it will be 1 minus. Now beta, this will be opened by the identity of a minus b whole square. So a minus b whole square will be equal to a square 9 sine square x, 9 sine square x plus 4 4 are 16 sine raised to the power 6x and minus 4 is 12 2 are 24. 24 sine raised to the power 4x. Okay, I have just applied the identity here. Now simplify it. This one will be cancelled by 1. Now sine raised to the power 4x equal to sine raised to the power 4x equal to minus 9 sine square x minus 16 sine raised to the power 6x and plus 24 sine raised to the power 4x. Okay, now transpose the term. I'm just putting all the term into LHS. So it will be 16 sine raised to the power 6x and then it will be plus 1 and minus 24, that will be minus 23 sine raised to the power 4x, and the lastly plus 9 sine square x equal to 0. Now I can take common if it is possible. Yeah, sine square x. So sine square x is the common factor. So it will be 16 sine raised to the power 4x minus 23 sine square x plus 9. Now I have two conditions: either sine square x will be equal to 0 or this will be equal to 0. So now if I put sine square x equal to 0, so I know sine is 0 whenever it is a multiple of n pi. So we will find the value between minus pi by 2 to pi by 2. So that will be minus 2 pi, minus pi, 0, pi and 2 pi. These values will lie between the interval, as you can see. If sine x is 0, so x always lie, okay, x is always equals to n pi. So I can put n is equals to 1, 2, 3, okay, and so on. So I'll be getting only these values for the interval. Now the second one, this can be equals to 0, 16 sine raised to the power 4x minus 23 sine square x plus 9 equal to 0. Now if I find the discriminant, that is b square minus 4ac, now it will be less than 0. You can see, if you find discriminant that will be less than 0, that means real root do not exist. So this will not be taken, because we need to find only the real values. Okay, only the real values. That's why I cannot take these. So how many values are there? 1, 2, 3, 4, 5. So option D will be the correct option. Option D will be the correct option. Okay, student, I hope these questions are useful for you. So now I'm going to end the class. So we'll take the next class soon. Bye bye, student.